What are pyramids? Pyramids have one face with at least 3 edges, and these faces, the faces meeting these edges, are all triangles. Notice that pyramids also come to a point up here, which is called an apex. So here's an example of a rectangular pyramid, a triangular pyramid, also known as a tetrahedron, which is one of the Platonic solids, and this is a hexagonal pyramid. Pyramids are similar to prisms where they're named by their bases, but they only have a singular base instead of 2 parallel bases. So here's examples of prisms and pyramids so you can see the differences and similarities between them. There's also a Quizlet that you can practice naming the polyhedron. Use those images above on the previous page and see if you can fill in this table, recording the number of faces, edges, and vertices for each type of prism. So for a triangular prism, how many faces are there? How many edges and how many vertices are there? Remember that faces are the lateral part of the shape. Edges are where 2 faces come together, and vertices are where you see all of those 3 faces come together. Okay? And you might be able to notice these on a net. Here's an example of a rectangular prism, and you can see that the face is the lateral surface. So in this rectangular prism, there would be 6 faces. An edge is where 2 faces meet. So you can see we have 4 edges here, we have 4 edges here, and we have 4 edges here for a total of 12 edges. And vertices are where 3 faces come together. So right here, like a corner. So vertices, we would have 1, 2, 3, 4, 5, 6, 7, 8. So in a rectangular prism, those are the numbers we have. So right now, we're trying to find a relationship between vertices, faces, and edges. Do all triangular prisms have the same number of faces, edges, and vertices? Why or why not? An n-gon prism is a prism whose bases have n sides per base. Write rules for the number of faces, vertices, and edges of any n-gon prism. Explain why your rule is valid. So the rule you may have come up with is Eulers' theorem. Eulers' formula is for any polyhedron that doesn't intersect itself, the number of faces plus the number of vertices minus the number of edges is always equal to 2. You could see it in a cube. There are 6 faces, 8 vertices, and 12 edges. So 6 plus 8 is 14 minus 12 equals 2. You can see Eulers' theorem here for the Platonic solids. And if you want to investigate it further, you can go to Math is Fun and look at that relationship. Thanks for watching.